Hello, everybody. Welcome to the Crypto Hipster Podcast. This is your host, Jamil Hassan, the Crypto Hipster, where I bring you entrepreneurs, founders, executives, artists, musicians, all kinds of wonderful people across the globe in crypto and blockchain. And I have an amazing guest today. I'm really looking forward to this interview because it's a really unique topic or interesting topic, not unique, but interesting, and has been beyond my grasp a little bit. But I'm really excited. And his name is Christopher Goes. He is the founder of Anoma. Christopher, welcome.
Thank you. Yeah, I'm not entirely sure into which of those categories I best fall. Just some guy. I used to think that, and still, it's still somewhat true, that privacy technology should really be built anonymously. It should, um, shouldn't matter where it comes from. Unfortunately, in a world of like a great amount of spam, ever more increasingly competent automated spam generation, that tends to be logistically difficult. So I've acquiesced to being a person, but let's see how that goes.
Awesome, awesome. Yeah. Um, I went to Hawaii in 2007, and spam was something that McDonald's served as a sandwich, and now it's a little bit more than that. But let me ask you, your background. What is your background, and is it a logical background for what you're doing now?
Oh boy, no idea. My background is well, in a technical sense, at least in college, it was mostly autonomous underwater robotics and philosophy. Um, Unfortunately, it turns out that mostly the only actual users of autonomous underwater robots that will pay you to do it are the American military and people contracted by the American military, and it wasn't really my cup of tea. Also, they're not super autonomous because autonomy is dangerous for military systems, which is good. I'm glad they're not super autonomous. But didn't want to do that. Spent too much time reading unusual internet blogs about coordination problems and ended up on this deep rabbit hole of investigating this weird data structure called a blockchain and whether or not it is relevant to anything. And that brought me here. In the meantime, also, or in between, I worked on the I2C protocol for Cosmos, which was very sort of inspiring for me personally as a kind of entry into how to think about this field. And I worked on a validator for a while. I worked on other kinds of entries into the protocol design space.
And you asked me a question before we began. And it's how do I come up with the name Crypto Hipster, right?
That's right.
Because hipsters are a lot of 20-year-olds, but and my brothers tell me that I should be calling myself the crypto hippie instead. But one of the definitions is somebody who doesn't wear fashionable clothes, and that's what I'm all about. So
Nice.
it's been a while. So since I
Yeah,
was
I mean,
trendy.
well, but it's a good. I always think that crypto has kind of a big aesthetic problem because a lot of people came in, especially in these recent years, from some completely different class of like money making middle management types, and they were just ruined the aesthetics. And I used to be, 4 years ago when I worked on crypto, when I would discuss the subject at dinner parties, it was like, dude, I have no idea what you're talking about. And I thought that response was fine because then we could have this interesting conversation about these alternative like systems. And now the question I get is like, do you have anything to do with the NFT ads in Neukölln? And I can just like try to say no. But luckily there's, US dollar values of things have gone down. So maybe that will calm for a little while. We shall see.
Yeah, a lot of NFT stuff recently. So, but I want to talk about Anoma, right? What is Anoma, and what is it all about, and what makes it great?
Right. Do you want me to cover mostly Anoma, mostly Namada? What should I focus on?
Well, not the mod was my next question, but you want to talk about both? It's fine.
Right. Let me kind of first give a brief exposition of of Anoma, and then specifically Namada. Obviously, there are too many names and it's confusing, so I'll try and keep it focused. So Anoma is our attempt to build a architecture from the ground up that is intent-based and that is privacy preserving. we're users of blockchain systems. So what that means, to spell it out, intent-based means that it's based on kind of this recognition that as designers of these blockchain systems, we're very interested in how they work. Like we think about virtual machines, we think about cryptographic protocols, we think about consensus algorithms, we think about all of these details. But users of these systems, as much as we might love to talk about it, don't care. They want the system to do something. They want it to do the thing they told the system to do, or they want it to do nothing, right? It should like succeed in the sense which the user has defined, or it should fail. Because otherwise the system isn't very safe. If the system does something the user didn't expect or doesn't explicitly authorize, it's not really capturing a clear semantics of something the user wanted. So that sounds a bit abstract, but to put it in practical terms, intents mean that instead of, many blockchain systems are based around this concept of transactions. So when a transaction is like when you use MetaMask, you're creating transactions generally. And when you broadcast a transaction with a wallet like MetaMask, you are broadcasting an imperative description of kind of what you want, like it's a call into the function of a smart contract on Ethereum. It specifies like some opcodes to do, some program to run, but it doesn't constrain what the system itself does. By contrast, an intent is declarative. So an intent says, I would like to, here's the input state of the system. I have this asset A, for example, and I would like to get this other asset B in at least this amount, and this should either succeed or fail. And in ANOMA, we're building a way of doing this for kind of arbitrary predicates that's composable, not only on the transaction layer, but also on the intent layer. So intents are not, whereas transactions are always involved a specific description of what state transition will be executed, intents just involve these preferences. And when you have intents which specify preferences, you can match them before you even create transactions, which is really nice for users because you don't need to think about gas in the same way or sort of fees in the same way. You are specifying what you might want the system to do, and there is some cost of execution, so you're going to be willing to need to pay some fee or take some accept some spread in your trade for execution. But the system is responsible for kind of doing that or not. And in this analogy, ANOMA is the system and you are not. So you only have to think about, as the user, what you put in your intent. And if you write your intent clearly, we have this network of distributed solvers, which are responsible for matching intents, putting them together into transactions and submitting them to the settlement layer, which is the sort of more conventional notion of blockchain. But that all functions according to what you put in your intent. And either it succeeds in satisfying your intent or it doesn't, and nothing else. So we're trying to build that kind of like realizing that from the system's perspective and from the user's perspective, these are two different perspectives, and trying to craft an interface for users that captures exactly what the system will do from their perspective, so they can ensure that it does what they want, and that also provides privacy, including in these intent matching scenarios and other kinds of properties that are desirable. So that all sounds complicated and long-term, and it is maybe I would hopefully not too complicated, where it's a set of abstractions that are individually simple, but the composition does sound pretty different than like maybe an existing system. And where some of the stuff, some of the zero-knowledge cryptography and consensus protocols, we're still in the process of prototyping. It's a good rule to not launch cryptography, less than a year after somebody invented it. So, in the spirit of that, and the recognition that it would be great to have private systems sooner rather than later, we have decided to build and launch Nomada. And Nomada is a proof of stake layer 1 or sovereign blockchain system that just provides private asset agnostic transfers. So there's ANOMA has this intent-based framework, it has this gossip network and counterparty preference matching. Nomada does not do that. Nomada is very simple. Nomada just does shielded or private multi-asset transfers. And why bother to do that, you might ask? Basically, two reasons. One of them is that privacy is this interesting feature in a systems design. Many features in systems are something like you have this program, or you have this database, and it currently does what you want, and then you realize like in the future that you want something else, and so you want a feature to be added, like maybe it's too slow and you have more data now and you just need to speed it up. Or maybe you so far have been doing these kinds of analytic queries on the database. Now you realize you want to do a different kind of statistical analysis. You want to add features. And most people think about features in systems like this. They're things that you can kind of add over time. Privacy, unfortunately, is not like this. Privacy is different. The reason privacy is different is that once your data is public, it is always public. You can't make it private later. You have to choose privacy up front. So if you want to design, sometimes you can like design versions of systems that are private. But if you're thinking about the data in the system itself, if you want that data to be private, you need to make that decision now. As soon as you make it transparent, you can't like later make it private. You could make future data after that private, but once you've released data in clear text to the world, it's copied on Google servers, on the NSA's servers, on servers, maybe they're the same servers, who knows. It's around in the world, and you're never going to be able to keep control of it again, no matter who tries to pass laws. It just doesn't work. So already we see many cases of the lack, at least personally, I would say the lack of financial privacy being exploited by actors with undue monopoly power. These tend to be states and governments. For example, the Canadian and Brazilian governments have both recently taken or tried to take various actions to freeze assets of people who supported nonviolent protests, which is an unusual thing for democratic governance to do. But now that they have the power to do it, it seems like it is too tempting, and they are not going to, adhere to any stronger notion of civil liberties, money, just because we've given them the power to censor these systems like that, and to we would like to treat privacy as this kind of asset neutral feature. So at the moment, many blockchain systems tie protocols to assets in a way that at least we think isn't so necessary. So for example, there's this term of a privacy coin, which is thrown about by sometimes developers, sometimes regulators, sometimes people trying to understand what's going on. And personally, I find it very confusing, because privacy in coins are orthogonal dimensions. A coin is just sort of defined by its initial distribution and who has distributed the coin over time. It's just an asset. Whereas privacy is a feature of a property of a kind of monetary rail or a financial rail. And with financial rails, you want to preserve scarcity. You don't want it to be possible to mint money out of thin air, and you want a clear notion of ownership so that only someone who owns money at a particular point in time can spend it. And you can get both of those things in a private system first. So for example, the Zerocash paper and subsequent Zcash project pioneered this strong So Zcash pioneered this strong cryptographic privacy guarantee with first their Sprout, then Sapling, then Orchard circuits, which implement the Zerocash protocol, originally defined in a paper from 2014, I believe. And this provides the kind of the properties you want out of a simple financial rail. It conserves supply, and it provides a strong notion of cryptographic ownership. And it also preserves privacy, so that observers of the system, in this case the blockchain, cannot see who is transacting with whom, how much they sent, when they sent it, anything like this. But receivers of money and senders of money can individually in their transactions see what's going on. However, what Zcash does at inception and still to this day is that it ties that feature set to a specific asset. So if you use the Zcash blockchain, you have to use the Zcash asset. And if people want the Zcash assets, sort of ownership set and supply, monetary issuance policy, that might make sense. But we just think that there are many people in the world who want with these strong private might want different assets, not necessarily our asset, to be clear, just like different assets. Some people might want an asset that's like a stable coin pegged to the US dollar or the euro. Some people might want their own assets. Maybe they want to do a kind of local community currency. Maybe they want a token issued by, maybe it's like a token issued by their neighborhood, a business association, which is used for transactions within that community. That's not really our business, in our view, as protocol designers, to specify what assets people have to use. We just want to provide kind of neutral infrastructure that allows them to get strong privacy guarantees when they use it. Sorry for the really long monologue, but I hope that helps.
Not a problem. You gave me a follow-up question there. that some people might be confused about this, including me, before I get into my next question. And you said you made a clear distinction there between tokens and being the crypto, being the access to the blockchain, and privacy being a feature. How would you define something like Monero?
Right. So Monero is a sort of older style of a blockchain. It uses a Nakamoto consensus protocol, so like Bitcoin, but with a different proof of work function. And on that blockchain, there is one asset, XMR, and Monero uses a decoy-based privacy scheme based on rig signatures. Which means that when you send a Monero transaction, an observer of the blockchain doesn't know exactly which inputs and outputs you used, but they know, like, basically there's a set of 8 to 10 transactions. This is based on my understanding of the Monero protocol from a year ago, so it's possible they've changed some of these parameters, but the scheme generally works like this. There's a set of 8 to 10 transactions, and the inputs could have come from any one of those transactions, but you don't know which ones. This is a much better notion of privacy than you get from a transparent system like Ethereum or Bitcoin, but it's still pretty linkable, as in if an adversary has if an adversary knows some of the transactions, they can have a better and better sort of statistical inference model of which transactions you're making are linked to one another. Whereas in the Zcash model, even if your adversary knows all the other transactions, if you and your friend are transacting and your friend is not the adversary, your transactions are private. The adversary doesn't learn anything about your interactions. We want to use this Zcash model in Namada, and Namada builds on some of that software because it provides this very strong and also very understandable notion of privacy.
So there's a couple things in the privacy and decentralization space that's going on that I knew of. Like, I wanted to get to your take what the current landscape looks like, and from if I look at some of the news articles, they look like the Department of Justice has gone after Tornado Cash, and companies like Accenture have created an editable blockchain. You mentioned before about it can't be edited or private, but in that case, I guess it could. Like, what are some of the issues, and what does the landscape look like right now?
That's a good question. I think the landscape is confusing, and I think the primary reason the landscape is confusing is because of a combination of misleading marketing and well-intentioned but kind of not super well-informed regulators, and a lot of parties buying onto hype trains without thinking, without necessarily understanding how exactly the underlying systems work. Let me take Tornado Cash as an example. So Tornado Cash recently, as you allude to, was sanctioned by the Department of the Treasury related to some, they claim it was because of some assets that North Korean hackers had been sending through Tornado Cash. There are a few things that are worth clarifying about this incident before trying to analyze it further. One is that, for reasons that I don't know, our Tornado Cash marketed it itself in a way that was pretty misleading. So Tornado Cash, if you go to their website, calls itself a mixer. And the Department of Justice or the Department of the Treasury, OFAC sanctions control action also describes Tornado Cash as a mixer. This is false. Tornado Cash is not a mixer. If you look at different blockchain systems, what does it mean to mix? So to mix means to kind of intermingle funds in a way that you're not sure where funds came from. Tornado Cash doesn't do that. Tornado Cash retains privacy for users, but users can still prove exactly where their funds came from. This is how also the traditional banking system works, and it's how general sanctions actions work. They identify specific funds that are held at some specific point in the banking system and prevent, or specific parties who are identified in the system and prevent American citizens from transacting with those funds or those parties. And Tornado Cash, regardless of whether or not sanctions were a good tool for foreign policy, which is a question for American citizens, Tornado Cash allows for all of those things. It's possible to identify specific funds, and it's possible for people to choose not to transact with specific funds or specific parties. So, I don't know what exactly happened in this series of events. Perhaps there was just a lot of miscommunication, but it's not, sanctioning Tornado Cash, like the protocol, doesn't make a lot of sense. To me, it implies a misunderstanding of what's going on. It's like sanctioning, COBOL. Like COBOL is the language used by banks to implement a lot of their, internal accounting systems. But if you sanction COBOL, you haven't actually, it's not clear what's being referred to. You might block, you might like cause some banks to stop operating, but it's not going to freeze specific funds or prevent interactions with a specific party because you haven't named the funds or the party. So I think that's kind of an unfortunate case of miscommunication, but it's not really like nothing in the underlying system is incompatible with what sanctions laws are trying to do. And the action taken doesn't seem to accomplish what one would expect sanctions laws are trying to do. So yeah, to me, it just implies a bunch of miscommunication. I think it's been made worse by just this like plethora of marketing. Tornado Cash had later on a token. It's not clear exactly why they needed that. It's difficult always in these systems because there's so much noise to figure out exactly what's going on. And I'm sure it's very difficult even for regulators with the best of intentions to figure out how they should protect their citizens. But I think that this state of affairs will be improved just with clearer explanations and less marketing speak.
So let's talk about that protection of citizens. This past 6 months have seen a lot of unprotection of anybody in the centralized finance exchange space, Celsius and BlockFi and Voyager and FTX and all that. So I know what damage these centralized exchanges have caused, but you focus on something else I've never heard of before. Maybe I have in a different term. It's called shadow centralization, right? So what is shadow centralization and what are some of the issues that exist because of it?
Shadow centralization? Did I say that somewhere?
You did. You did. That's where I got it from. So what is shadow
Gotcha.
centralization?
Well, it's a cool term. I must have forgotten that I said it, but I mean, I think what I would probably use that term to refer to is that there's a lot of semantic. Here's a good term. There's something which I like to call semantic arbitrage, which is when some concept, let's take decentralized finance. Decentralized finance is a sort of interesting idea, right? What exactly does it mean? Well, usually it means something like we have this current financial system and it tends to be operated by trusted third parties, by a bank or by a clearinghouse or by these sort of human institutional operations which are supposed to be enforcing a set of rules around who can send money, how that money can be sent, how these different financial assets can be created, stuff like this. And the idea usually of decentralized finance is to instead build a kind of more build a programmatic computer system to enforce these rules where instead of there being one operator with a bunch of spreadsheets, there are a lot of operators like a validator set of a blockchain such as Ethereum or Solana. This is a distinction in technical architecture. It's not a distinction in tokens. But there have also been many tokens associated with these decentralized finance projects. And companies such as FTX or BlockFi or Celsius describe themselves as being in the decentralized finance ecosystem and doing something with decentralized finance. And this, I suspect, attracts interest because people think that decentralized finance might be a sort of fairer or more trustworthy way to run these systems. Unfortunately, this is a lie, or it's just, because the term lacks a clear definition, it's hard to know to what degree exactly things are truthful. But BlockFi, Celsius, and FTX are textbook centralized financial operations, and the fact that they use particular cryptographic tokens is really unrelated to how they operate, and it is how they operate that cause them to fail. But I think it is this gap between the kind of marketing of these companies and the actual underlying protocols that led to this kind of obviously big discrepancy in what people expected was happening and what was actually going on under the scenes, under the hood.
Yeah, I agree. I definitely agree. Um, so sticking with, with privacy, privacy to me, it seems like the regulators are attacking privacy, right? Why is privacy more important now than it has ever been before? And why are they attacking it, or so it seems they are?
Right. Uh, well, I am not a regulator, so I don't know all of their intentions or motives. But I suspect that a lot of what's going on is simply that there's a lot of confusion in how these systems work and who is deploying them. This is frankly made worse by entities like Celsius, BlockFi, and FTX, which spend a lot of time schmoozing with regulators and having dinners and ingratiating themselves in the Washington D.C. scene and talking up a storm about how they're the new decentralized financial sector or whatever, and then don't actually do that. And I think this makes the situation much worse, especially when they're hiring influencers to market with television ads. Um, the specific question of privacy, I think, is um, probably there are a great mix of intentions and motives. I mean, the governments tend to like additional amounts of control over systems, sometimes nominally for the purpose of protection, sometimes perhaps just because they want to, advantage some specific party. There are many companies which benefit from privileged relationships with government. They probably don't want competition, like the banking sector, which is gigantic, unnecessarily benefits from close relationships with government. They probably don't want competition. So there may be influences in that direction. Certainly, for example, the Canadian and Brazilian governments have taken specific actions to suppress dissent within their countries that are in part enabled by their control over the financial system. Once given, that control is difficult to give up. The US government tried to ban cryptography unsuccessfully in the 1990s before there were any cryptocurrencies, just in the days of PGP. I think because they realized that it was finally some communications which they might not be able to intercept and spy on, and that seemed scary. This is not a new battle. I think it's a pretty continuous one, but the stakes are higher now than they have been before because the ability, let's go back to the year 1850. So in 1850, there was a little bit of like cryptography, but there were no computer systems, there were no fancy cryptographic financial systems, nothing like this. However, the cost of surveillance was pretty high. In order to surveil, people used cash. Cash is very private. And in order to surveil an individual's transactions, the government had to hire somebody and send that person to their house or talk to people. The cost of surveilling individuals was non-trivial. But now we have all this dragnet surveillance. Data is just captured, it's gathered up by servers, by telecommunications providers, by kind of a small number of companies which have a strong monopoly over user data, and the government can easily sort of fetch data from. And that makes the cost of surveillance very, very low. So private technology doesn't, the government still has police as long as we live in that equilibrium at least. So it doesn't prevent individual surveillance or doesn't prevent the kind of techniques to, it doesn't prevent the kind of power balance that previously existed. But what it does prevent is this sort of dragnet surveillance of everything where large companies and the government can get whatever data they want without having to go through any kind of civil process and without having to pay any kind of cost for individual investigations. So I think there will be a sort of tussle over this because we have, as a society, been a little bit, it was just not clear what the impact of these large-scale digital systems would be. And early on, many of the operators of the systems were more ideologically driven and would have hesitated to give away data for free to the government or sell it to people. And over time, most of these systems have just become captured by kind of autonomous Wall Street profit maximization functions, and they don't care about any sort of individual protections anymore. They're just selling their data to the highest bidder. And unfortunately, we've become locked into this equilibrium, like into Google accounts, Facebook accounts, Twitter accounts, and it's hard to shift out of it. It will require a bunch of collective action and alternative systems design and building and negotiation with the sort of people in the current structures of power. But I don't think it will. You cannot regulate out cryptography or information technology. It's like trying to regulate the laws of physics. It's out of the bounds of human systems. So eventually privacy will win out. It's just a question of trying to craft a kind of peaceful transition in my mind.
So most of our conversation so far has been about there's two sides of a coin, right? We've been talking about the tail. Well, let's flip the coin and talk about the heads, right? Because no one's talking about the head of the coin. They're always talking about the tail of the coin with surveillance and everything. But with the head of the coin, what could be or should be the value of economics from having privacy?
Right. So privacy is an interesting kind of good. Many goods in economics are scarce, such as currency. So if we have a $5 bill, either I have the $5 bill or you have the $5 bill. We can't both have it. And that's a property that we generally want in currency. We want it to be scarce because it allows us to track goods in the physical world which are scarce. On the other hand, privacy is cumulative. So if we think about an anonymity set, let's say there's an observer looking at a $5 bill. And if it could have come from me, they know it came from me. If it could have come from me or you, they know it came from one of us, but not which one. If it could have come from me or you or a mutual friend of ours, the privacy set gets bigger and bigger and bigger. In Namada and in these kinds of, you can build systems such that this agglomerates across multiple assets. So when observers look at the model, a Namada blockchain, they see transactions, but they don't know who sent them, who sent the funds, who received the funds, how much the funds were, or which asset the funds were. Which means that the more people use Namada with different assets, the more privacy everybody has. So it's kind of win-win. The more users use the system, the more privacy all of the users of that system receive. But still, privacy suffers from a kind of bootstrapping effect. So if you have a system with a small number of users, because the anonymity set is small, there's not that much privacy. And in Namada, we've tried to craft an incentive structure which rewards early users of the system who start out by providing privacy with the expectation that then, later on, the anonymity set of the system will be large enough that new users have enough reason to join just by virtue of it already being quite private. But in order to speed the transition to that point, we grant rewards to early depositors into the Shilda pool. Does that make sense?
That makes sense. Awesome. So, how do you so a lot of people told me that the future of crypto and blockchain is multi-chain, right? Multi-chain and interchain and however else, and the relationships with one another and communication, right? Why is that important, and what are you doing to help the communication improvements?
Right. I think an important question to ask in this context is, what are blockchains doing in the context of deployed systems? One other piece of sometimes misleading marketing is to say that blockchains are trustless. Blockchains are not trustless. Blockchains make trust explicit, which is very useful. So they specify which parties, and usually they specify this cryptographically, which public keys, and which quorum of those public keys you have to trust in order to know that the system sort of follows the rules that you expect it to follow. It's great to have explicit trust relations, but it's not the same as a trustless system. Many of the problems that blockchains try to solve, like distributed consensus, cannot be made trustless. Like there's just no, you cannot solve the Byzantine generals problem when more than the generals are Byzantine. So you have to make some assumptions. Different people, though, probably don't necessarily want to make the same assumptions. In particular, when we're talking about economic systems, often we want economic systems to have kind of local resilience. So if I'm doing a transaction within my town or within my community, there's no real reason to go outside that community and rely on someone outside that community to settle that transaction. In the context of blockchain systems, this means that we need to have different blockchains with different security zones for each of these communities so that they can settle transactions within that community without relying on anyone outside of it, which introduces an extra and unnecessary point of failure. So I think for this reason, interoperability is very useful because it allows people to use the kind of most local system, but still interoperate within a larger network. If you have to choose between one or the other, it's very hard because you have to give up either you give up local sovereignty or you give up the benefits of a greater scale of cooperation. So on the Nomada front, we're just trying to make it as easy as possible for people to send whatever assets they already have or issue elsewhere to and from Nomada. Nomada supports the IBC protocol, which is part of the Cosmos protocol stack that I worked on previously, and it has an integrated bridge to the Ethereum blockchain. So if your blockchain or asset speaks IBC or can either is located on already or can talk to Ethereum, you'll also be able to use Nomada, and Nomada is kind of non-discriminatory with regards to where assets come from. They're all treated equally in the Shield pool and receive that sort of shared privacy of everyone using the system.
That sounds really good. So, yeah, awesome. So,
yeah, I mean, it's very practical, to be honest. It's not. There's nothing revolutionary in distributed systems design or cryptography going on here. So we've built upon the great work of Zcash, added multi-asset support. We've built this reward circuit for greater kind of economic compatibility of private transactions. But by and large, with Nomada, we're just trying to make privacy practical and make it practical now. Because the more data we can keep private now, the less surveillance we have to worry about in the future.
so you address both sides of the coin, which is great. So I want to thank you very much for your time today. This has been an insightful and educational conversation for me, and enjoyable as well. And I have one last question, and it's this: how can people find out more information about you, about Nomada, about Anoma? How can they do that? How can they reach out to you or get to know more?
You could find out about Nomada and Anoma on nomada.net and anoma.net. There's a great blog actually at blog.nomada.net, which has a blog post, actually several, describing the protocol in a bit more technical detail and explaining the history of its development. And you can find on the Anoma website links to our papers that describes the systems and our motivations for building them. And you can find me on Twitter at CWGoes.
Awesome. Thank you very much for your time today.
Thank you.